Welcome once more, beautiful matriculants. My name is Katlego Nakedi, and on this lesson, I'll be covering another exciting topic of differential calculus. And as you can see with the heading there, it's called equation of a tangent line. Not a big and a difficult topic, and yeah, you will see when I start doing the problems that basically this is what you've already covered previously, either in earlier parts of your differential calculus, like your functional notation and so on and so on, and also what you've already covered in your analytical geometry and other chapters. Okay, so yeah, this is not basically this is a very short topic, and I'm not gonna waste time. So with having said all that, let's look at what this equation of a tangent line is all about. Okay, so firstly I'm going to draw a graph. I'm going to draw a graph so that I can explain where this tangent line comes from as a quick reminder. Okay, so suppose I have a curve, a parabola, a parabola going like that. That's your y, that's your x, that's your origin. Okay, so this is in the form y is equals to ax squared plus bx plus c, and I have a tangent, which I believe now you know how this tangent came about. Okay, so I have a tangent passing there, touching the curve at one point. So touching there. So what we need to know about this equation of a tangent line, remember we're dealing with calculus, so we are dealing with derivatives. So what you need to know about this tangent, especially at this point with x and y, or with x and f prime x, what we need to know is that the gradient of a tangent, or let me start by saying the gradient of the curve is equals to the gradient of a tangent. Okay, so, and you know that for you to get the equation of a tangent or equation of any straight line, which will be in the form y is equals to mx plus c. Remember, this is a straight line. For you to get the equation of that line, what do you need? You need the gradient, and also you need the gradient, and you also need 1 point with coordinates, 1 point on that particular line, on that line. So basically we need this line. You need that x and y, and then you can substitute that to find the equation of that tangent line. Okay, so there are a couple of things that you need to know when determining this equation, the equation of a tangent line. So you will take your general equation, which will be ax squared plus bx plus c, and you will find the derivative. Basically, you will find the derivative of the curve, so which will be f prime x is equal to, this will be bx, 2ax plus b, and then that will be your gradient. And then after calculating the gradient, you can use that gradient of a curve and equate it as a gradient of the tangent, because we see that when these two points, these two graphs meet, they share and they have the same gradient. and then you can be able to calculate the tangent, the equation of a tangent line. So to explain all of this, I'm going to do 3 problems so that you can see how to go about in terms of solving this equation of a tangent line. Okay. And the example is as follows. It says, given g of x is equals to 2x squared plus 1, determine the equation of a tangent line to the graph of g at the point where g prime x is equals to minus 8. So what is required of us is to determine the equation. So in the form y is equals to mx plus c. Okay, but we can see that we are given the derivative of the curve. So we are given g prime x, which is the derivative of the curve. The derivative of the curve is the same as the derivative of the tangent, which is equals to minus 8. And I hope you understand when I say the derivative of the curve and the derivative of the tangent. Basically, I'm talking about the gradient. Okay. Now, like I said, for you to determine the equation of a tangent line, you need the gradient and 1 point. So for me, what I need to do now is to determine that particular point. So what I will do, I will say, okay, if I can differentiate this g of x and equate the g prime x as minus 8, I can solve this x. And then I will take this x and substitute it in the original formula, the original equation, to get the corresponding y value. Okay, so this is what I will do. I will say, okay, I'm given g of x is equals to 2x plus 1. I will differentiate this. Remember, we're dealing with calculus. So I'm going to differentiate this, and this will be g prime of x is equals to, I look at this, I ask myself, do I have roots? No, I don't have roots. Do I have brackets? No, I don't have brackets. Do I have fractions? No, I don't have fractions. That means it's fully simplified. I can apply my rules of differentiation. Okay, then if I differentiate, I will get, this is 2, I direct 1, so 2 minus 1 is 1. And the derivative of a constant is 0, so this will be 4x. And I say, oh no, but I've been told that g prime x is equals to minus 8. Therefore, I can substitute and say minus 8 is equals to, yes, 4x. So minus 8, it was there. So it's equals to 4x. Therefore, x is equals to minus 2. So now I have, remember I'm looking for coordinates. I have that x as minus 2. Now I need to get the corresponding y value. Listen carefully, grade 12. When calculating the corresponding y value, and you must also note this, you substitute x, in this case x is minus 2, in the original. Which one is the original equation here? It's this. You don't substitute here at g prime x is equals to 4x. No, you substitute in the original equation. So this would be g of x is equals to 2x squared plus 1. Functional notation, it's here again. So this would be g of minus 2 is equals to 2 into minus 2 squared plus 1. And this will give 9. So the corresponding y value there, it's 9. Now I have a gradient and I have 1 point. I can say I have an equation, the general equation, which says y is equal to mx plus c. Or you can choose to use this one, y minus y1 is equal to m into x minus x1. That will depend on which one you prefer. I like this one, or I will use this one for this particular example, and on the next example, if the question is similar to this one, I will use this. Okay, so what is my y? If I substitute my y, I substitute my gradient, which is minus 8. Then my x value will be minus 2, y value will be 9, and then I'm solving c. After solving, you'll realize that c is equal to minus 7. Therefore, the general equation of a tangent line for this particular problem is going to be y is equals to minus 8x minus 7. And that is the equation of a tangent line. Now, example 2, it says, calculate, determine, evaluate the x-coordinates of the points on the graph of f of x is equal to x cubed minus 7x squared, at which the gradient of the tangent to f is equal to 5. Okay, let's read that again to understand what the question wants. Calculate the x-coordinates. This is very important, coordinates. So automatically this shows you that we're gonna get two x values. Of the points, again, this also shows that we've got two x values that we're going to get. To the graph of f of x is equal to x cubed minus 7x squared, at which the gradient of the tangent to f is equal to 5. So, according to my understanding, there's a cubic graph that says x cubed minus 7x squared. So this cubic graph, okay, I will explain this when you get the x values so that I can show you what this statement actually means. So, but in general, this says we've got the general equation, the cubic graph here, and the gradient of the tangent to f is 5. So now they're giving you, in the previous example, they give you the equation of the curve, which is the same as the gradient of the tangent. In this example, they give you the gradient of the tangent, which we know that is the same as the gradient of the curve. And in this case, is equals to positive 5. Now, this is the equation of the curve. It's the equation of the curve. So we need to differentiate this and equate it to 5 and solve for. Okay, so I'm going to differentiate this and say, okay, I'm given f of x is equals to x cubed minus 7x squared. Now the question is this fully simplified? Can I start applying my rules of differentiation? Remember, in terms of differentiating, you can either use rules or first principle. But why you waste time using first principle when you can apply rules here? Because the question didn't say use first principle. Okay, so we're going to apply our rules here. I don't have roots, I don't have fractions, I don't have brackets. So I can say my derivative will be f prime x is equals to, I'm sure now you're confident enough to solve this quickly. This will be 3x squared minus 14x. Okay, but this f prime x is the same as the gradient of the tangent, which is the same as the gradient of the curve, which is equals to 5. So I can substitute and say 5 is equals to 3x squared minus 14x. Remember, I must calculate the x coordinates. So I have to factorize this. This will be 0 is equals to 3x squared minus 14x minus 5. What did I do? I took my 5 from the left hand side to the right hand side and I changed the sign. This is what is known as the law of conservation of mathematics. What you do on the left, you also do on the right. Now I'm going to factorize this. This will be the same as 3x x. What are the factors of 5? Factors of 5, I will put 5 there. I will put 1 there. The bigger number, take the sign of the middle term. This will be minus 5. This will be positive 1. Okay, you can FOIL check if it's going to give you this 3x squared minus 4x minus 5. Okay, therefore, x is equals to -1 over 3 or x is equals to 5. Now we solve the question. But looking at this, what does this 2x values mean? It means that this curve will look like is a cubic graph with 2 turning points. Or if I had to draw this, I will have a situation whereby I have a tangent. I have a tangent touching there and a tangent touching somewhere there. So I have a tangent touching there and a tangent touching there. This one will touch at x is equals to -1. This will touch at x is equals to 5. Now, these two tangents, they have the same gradient of m is equals to 5. M is equals to 5. That's why we're getting 2x values, not 1. Okay, I hope that makes sense. We will now move to example number 3. Now, example 3 is as follows. It says, given h of x is equals to x cubed plus 4x squared plus 8x, determine the equation of the tangent to h at x is equals to -2 in the form y is equals to mx plus c. Again, grade 12, this is another form of asking questions on equation of a tangent line. You will see now this one is different to the two examples that we did before. In this example, they are giving you the x value where the gradient of a tangent line and the gradient of the curve are equal. But we still need to follow the same principles so that we can end up with this the equation of a tangent, which is in the form y is equals to mx plus c. Okay, so we are given h of x. That's the first thing, which is x cubed plus 4x squared plus 8x. So since we are not given the gradient, we are going to differentiate this so that we can get the gradient function. Okay, not the gradient function, and then substitute this x value to get the actual gradient of this curve, which is the same as the gradient of this tangent. Okay, so remember, this is calculus. We're going to differentiate and say, but before you differentiate, you ask yourself, do you have roots? There are no roots. Do you have fractions? There are no fractions. Do we have brackets? There are no brackets. So I can apply my rules here and say h prime of x is equals to, this will be 3x squared plus 8x plus 8. I'm sure you know how I got that. If you're still struggling with this, make sure that you watch previous video that I did on rules of differentiation. Okay. And then now I'm going to apply my functional notation concept. I want my derivative at x is equals to -2. So I'll say, okay, what will be h prime of -2? This means that where I see x, I substitute -2 squared. There's a 3 there, plus 8 into -2 plus 8. Okay, this will give 3 into, what is 2 squared? 2 squared is 4 plus, or not plus, negative -16 plus 8. 3 times 4, 4, 8, 12, minus 16 plus 8. This will give 12 minus 8, and this will be not 8, yes, 8, and the answer that you'll get is going to be 4. I hope I'm right. Let's get a calculator and confirm that. So we've got, if I can just move this calculator, Okay, we've got yes, that's what I wanted. So if I've got 3 into minus 2 squared plus 8 into minus 2 plus 8, this will give 4. Okay, that's correct. Now what is it that I've calculated now? This is the gradient of the curve. So I've calculated the gradient of the curve. Gradient is the same as the gradient of the tangent, and it is 4. So what do I need now to my equation of a tangent? I need one other point. And I know that for this, I already have the x value of that particular point, which is minus 2. Now, I must get the corresponding y value by substituting in the original equation. By original, I mean the one that is not yet derived. Okay, so what equation is that? It says h of x cubed plus 4x squared plus 8x. Okay, I substitute h of minus 2. Functional notation again. It says minus 2 cubed plus 4 into minus 2 plus 8 into minus 2. This will be going to get the calculator again. This is going to be into minus 2 cubed plus 4 into minus 2 squared plus 8 into minus 2, and this will give minus 8. Okay, so I've got minus 8. So my corresponding y value is minus 8. Now I can substitute this in the general equation of a straight line, which says, for now we'll use y minus y1 is equals to m into x minus x1. Remember, you can also use y is equals to mx plus c. The most at the end, it must be in this form. So what is y? I don't know y. What is my y1? I only have y1, which is minus 8, is equals to, what is my gradient? My gradient 2, and minus is going to be positive 2 squared. Okay, close bracket, sorry. This will be y plus 8 is equals to 4x plus 8. And then what do I do from here? Law of conservation of mathematics. I move this 8 to the other side. Remember, what you do on the left, you also do on the right. And this will be y is equals to 4x. Okay, and this will complete this problem. Since they want the c value, you can also say this is plus 0, but it's not really necessary. So this completes the problem of example 3. So grade 12s, I hope this lesson helped a lot. Like I said, this section, it's not a big section. We'll also see in your test, in examination, it will be like a 5 marks a problem, or 6 or 4, not more than that. And sometimes they won't even ask this question, but it is important for you to understand the concept, the basics, which is what these tutorial videos are all about, giving you the basics so that you can be confident enough to solve any differential calculus problem that you come across. So until we meet again once more, take care and continue studying hard. Bye.